Welcome to Brain Vision.
So we'll choose a compass like this. Rightwards is eastwards and upwards is northwards. Now the postman has moved 2.6 kilometers northwards and then 4 kilometers eastwards and then 3.1 kilometers at an angle of 45 degrees north of east. Now we need to find the resultant displacement from here to here. Hence our resultant displacement vector would be this. Now we can find out the vector's magnitude and direction by finding out its x and y components. Now because the 3.1 kilometer vector is at an angle of 45 degrees, we can see that the x component, that is the eastward component, is 3.1 cos 45, whereas the y component is 3.1 sine 45. Now by plugging this into a calculator, we can see that both of them are equal and they're equal to 2.19 kilometers. They're equal because cos 45 is equal to sine 45. Hence, this distance is 2.19 kilometers and this distance is 2.19 kilometers. Now, we can see that if this is the final displacement vector, its x component is the sum of 4 kilometers and 2.19 kilometers, which would be 6.19 kilometers. And its y component would be 2.6 kilometers plus 2.19 kilometers, which would make it 4.79 kilometers. We can find out its magnitude using Pythagoras theorem. It would be the square root of the sums of the squares of the sides, which would be 6.19 squared plus 4.79 squared. By plugging this into a calculator, we can see that this is equal to 7.83 meters. Now we also need to find out this angle. Now if we call this angle theta, then its opposite side would be 4.79 meters. Now we can write tan theta is equal to opposite side divided by adjacent side, which would be 4.79 divided by 6.19. Hence, theta would be equal to tan inverse of 4.79 divided by 6.19. By plugging this into a calculator, we can see that this theta is 37.73 degrees. And because this is eastward direction and we are turning north, this would be north of east.